the second lesson from the same one. This is lesson 7.1. So we're going to talk about what if I want to raise a power to a power. And today's date is 3/9. So for example, what if I wanted to take x to the 5th and I wanted to raise it to the 3rd power? So I want to cube x to the 5th. Okay, well, remember what exponents tell you, it's how many of that base we have. So let's start with the outermost exponent. It says you have x to the 5th times x to the 5th times x to the 5th. And what we could use at this point is the rule from Monday, which, I'm multiplying the bases are the same, so what would I do with those exponents? I'd add them. Or we could expand them out. So this gives me x 2, 3, 4, 5. So that's the first one. Second one, 1, 2, 3, 4, 5. Third one, 1, 2, 3, 4, 5. Okay. Now I can add them all up. How many x's do I have altogether? X to the 15th. So the question is there a faster way of getting that answer? Lainey?
Just multiply the 3 and the 5.
Yeah, so the simpler way would be, if you notice, you had an exponent of 5, and you raise that to the 3rd power. It's the same as saying take those two exponents and multiply them together. So that's the rule for power to a power. So power to a power rule. I'll highlight that. And it says if you're taking a base, I'll use A's, and it's being raised to a power, and then you decide to take that entire power and raise it to another power, then what you're going to end up doing, the rule says that will save you all this time of drawing it out, is you're just going to multiply those exponents together. Okay? And so I've got a couple different situations. I'm going to go through some problems of this kind, and then we're going to go back and talk about, well, what if there's a coefficient involved? How do we deal with that? Okay, so let's do some examples that deal with just this portion of it. So the examples are going to say simplify. So if you want to do these on the other side, you can. I'm not exactly sure how much room it's going to take. So simplify says do all the math that you can do until there's no more math to be done. So we've got 2 cubed, but I want to square that, but then I want to raise that to the 4th power. So instead of working from the outside in, order of operations says work from the inside out. So in the inner parentheses, I have 2 cubed. Can I simplify 2 cubed? Well, if I wanted to, I could say what 2 cubed equaled. But that's going to take it out of the running of dealing with exponents. So I'm not going to do that. So now I have brackets. And in the brackets, I see an exponent. So what are we supposed to do in the brackets with the exponents when I'm raising a power to a power? Yeah, we're going to multiply those. So we're going to do 3 times 2. But we still have this guy on the outside. So we simplify. No, it's a 2. It's going to stay a 2. So now we've got 2 to the 6 is what's inside the brackets. But now I've got another problem left to do. So it says, okay, now you have to deal with the second exponent. So what am I supposed to do with the exponents now? Yeah, I'm going to multiply again. So I have a 6 times a 4, and I get 2 to the 24th power. Now, when you have a situation like this, is there a faster way of getting that answer? Say again? Yeah, because I'm a power to a power to a power, I can just use the rule in one shot. So I would have 2 times and then the exponent would be 3 times the 2 times the 4. So I'm going to grab those exponents and multiply them all together. So we get 2 times 3 is 6, and then 6 times 4 is 24. So we get to the answer pretty quickly if we just use the rule. Okay? All right. We'll do one more like that. Just an easy one like that. So what if I have 3 and it's raised to the third power, and then I want to raise that quantity to the second power, and then I want to raise that quantity to the fifth power. So let's just do this orally. What would I get inside the brackets if I take 3 cubed and I square it? I get 3 to the 6. Now if I go to the rest of the problem, I have 3 to the 6 to the fifth power. What is that going to give me? 3 to the 30th power. So we basically just take those 3 exponents, power to power to power, and we can multiply them to get this. Now notice what didn't change. What stayed the same in this whole problem? The 3. The base does not change. Okay? I don't know how to emphasize that enough to you guys. When you have a numerical base, it stays that numerical base. It's not going to change. Okay? Now, let's throw in a little wrench, and let's throw in a coefficient in addition to a base. So this could go back to the note side if you want to do it. So let's say you have something like this. 2x to the fifth, and you want to raise that to the fourth power. Okay, well, fourth power says I have 2x to the fifth times 2x to the fifth times 2x to the fifth times 2x to the fifth. I have 4 2x to the fifths. Okay, so thinking back to what we did on Monday, how should I rearrange this problem?
5 times 4.
Okay, no, that's not rearranging. How should I rearrange this problem? Is that Lainey with her hand up?
You could put all the 2's together and all that.
Yeah, we're going to put like things together. So we're going to put coefficients together, and we're going to put variables with their exponents together. So grouped in this, we have a 2 times a 2 times a 2 times a 2. So that's 1, 2, 3, 4 of them that are there. Okay, and then we're going to multiply it by, variable-wise, we have x to the fifth, x to the fifth, x to the fifth, x to the fifth. So we have x to the fifth times x to the fifth times x to the fifth. So how many 2's did I end up with? How many 2's? Not how much. How many? 2. I had 4 of them all together, and the reason why? Because they showed up 4 times. So I could say this is 2 to the fourth power. How many x to the fifths did I end up with?
4.
And I ended up with 4 of them. So looking back to your original problem, can you see what's happening when you have more than one base, a coefficient and a base? Okay. Can you see what's happening when you're raising that power to a power? Patrick, what do you see?
The 4 outside the parentheses is like being distributed to each base.
Exactly. The 4 is being distributed to each base. Now, distribution deals with what operation? Multiplication. And that's precisely what we're going to do, because now we're going to use the rule we just talked about when we have a power to a power. So 2 to the fourth power is not 2 times 4. It's telling you how many times to multiply 4 by itself. So that exponent gets distributed, and then we're going to interpret that as a multiplication problem. So with the 2's, we go back to this notion, and what's 2 times 2 times 2 times 2? 16. Now again, you probably are going to get very familiar with 2 to the multiple different powers, so you would need to expand it and then do step by step, but you always have that as your failback. If you know If you can't figure out what 2 to the 10th is, then you can break it down into something you do know. Let's say you know what 2 to the 5th is. And to get to 2 to the 10th, I'd have to have 2 to the 5th and a 2 to the 5th. What's 2 to the 5th power? Anybody know off the top of their head? 32. So then you end up having 32 times 32, and then that you would have to multiply. So all sorts of different ways to do this. All right, now let's look at that x to the 5th power raised to the 4th power. So what would be the final power on that guy? It would be a 20. Okay. So this exponent gets distributed. Distribution deals with multiplication. In the terms of the coefficient, it's being raised to that power. But in terms of the variable, that outer exponent is going to multiply with that inner exponent. So when they ask you to simplify, you don't leave it as 2 to the 4th. You need to give me a value for the 2 to the 4th. You need to tell me what its value is. Its value is 16. Okay? Let's do, there's an interesting problem in the book. So we can go back to examples. Go back this way. Directions are still going to be the same, still simplify. And basically what they've given me is a couple pieces of information. We have a circle. And they've given me this piece of information, 2xy squared. What part of the circle are they describing? Radius. Yeah, they're describing the radius. And let's say they wanted you to figure out the area of the circle. Please. Does anyone know the formula for the area of a circle? Okay. I want a formula, so I better hear an equal sign in it.
Area equals radius times pi.
Okay. So how we write it, area equals pi times r squared. Okay. Radius squared times pi gives us our area. So what if they want us to figure out the area of this particular circle? All right, well, let's plug in what we know. Pi stays as pi. And by the way, in geometry class, if you're asked for an exact answer, you leave pi as pi, because that is exactly its value. If they want you to give an estimated answer, then you're going to use a version like 22/7, 3.14, 3.14159, whatever the dictate is from your particular teacher for how many decimals after the decimal point, or digits after the decimal point your answer needs to be. But if you are asked for an exact answer, you leave it in terms of pi, okay? Because we cannot give an exact answer for pi, because pi is non-ending, and we haven't figured out exactly what it is. We have an idea of what the first, 1,000 digits or whatever it is are. But so now what we're going to end up doing is taking that radius, which is that 2xy squared, and we're going to, according to the formula, square it. So notice where that exponent of 2 is on the outside. Does it touch the pi? No, pi doesn't have it. It doesn't get distributed to it. That exponent is only connected to what's directly in front of it. What's directly in front of the 2, the exponent 2, is a parenthesis. So that says that red exponent 2 is only connected to what's inside the parentheses and not beyond. Okay? So we're going to go ahead and see what we can come up with here, and we're going to apply our rules. So pi stays pi. He's not going to change. We're going to take our 2 and we're going to raise it to the second power. Why? Because that's what we're told to do. Now, I'm going to kind of beat a dead horse here, but I want to make sure you understand this. Now, for the next 2, because they're variables, you should see multiplication going on. The question is, what is the exponent on that x? They didn't tell me it.
1.
Yes. So if you don't see it, it's there. And honestly, guess what the exponent on the 2 was?
1.
It's the same thing. So there's multiplication is taking place with that exponent on the outside to the exponent on the inside. If you don't see the exponent on the inside, you see a 1. How is 2 to the first power?
No, I thought you were talking about
Okay, all right. Just making sure we got this down. So now we're going to raise the x to the second power. Now the y has an exponent of 2, so we'll keep that 2. And now we're going to multiply it by that outer exponent. So we get area is equal to pi. We get 2 squared. We get x squared. We get y to the 4th. Now that answer is not right yet. What do I need to do to finesse my final answer? Bryce? Oh, I'm talking to Bryce. And what do you get? Okay, so I get pi 4 x squared y to the 4th. Labeling or order-wise, that's not quite right. We need to adjust the way that answer looks, because what should be the first thing I see?
X.
Nope. Nope. What's the very first thing I should see in this answer?
Not power. Coefficient.
The coefficient. So the 4 goes in front. Then what would come next? The x squared and the y squared, or y to the 4th. The last is the pi. The pi is kind of like a label. It's going to go at the end because it is a constant, whereas x and y, we don't know what they equal. So we'll put the constant there at the end. Now, honestly, we should do a label on here. I didn't tell you any measurements. It's an area answer. So if I had to give a generic label to an area problem, what would I write as my units of measure? Square units. When I don't have inches, feet, meters, miles, I say square units. The other way to write this would be 4x squared y to the 4th pi, and then units, and the exponent of 2. Now, we don't read that as units squared. We read it as square units. Okay, so they mean the same exact thing. All right, let's see if I can find another. Ooh. So now what we're going to do is we're going to put together the two rules. So we're going to have a power-to-power rule in play, as well as multiplying monomials. So that's going to be a big gist of what your homework is tonight. So last example, I might give you a couple of them. So we've got 3x y to the 4th, that quantity squared, and then I'm going to multiply that by the quantity negative 2y. I want to square that, and then I want to cube that. So order of operations, don't need to bring the Lord into this. Just need to bring a paper, pencil, and your brain. Okay? I'll do the praying for you. Order of operations holds true even when it deals with variables and exponents. I take care of what's inside of grouping symbols first. In the first set of grouping symbols, I have a monomial. I can't simplify a monomial. In the second set of grouping symbols, I do have something going on. I'm being asked to square a quantity. So I'm going to take care of that. So for the time being, 3xy to the 4th, quantity squared, is going to stay. Inside the brackets, I'm going to take negative 2y and square it. So how this looks, so I'm going to take the negative 2 and square it. I'm going to take the y and square it. Now I still have an exponent of 3 on the outside. Now, this particular step is what I would call a brain step. So this isn't what my brain is doing. The outcome is this next step. So 3x y to the 4th quantity squared still is there, but now what I have, what's negative 2 times negative 2? Positive 4 y squared cubed. That's what I'd be writing as the blue step. I would not be doing the black step above it. And again, the reason why is I should be able to square negative 2 and square y in my head. Okay, those are some things that I should be able to do. If you're struggling, then you're going to show me that brain step. If you need to struggle more and you need to show more, then you're going to write negative 2 times negative 2. Whatever it takes, guys, for you to get this answer right, you're going to have to do it until you have enough practice with this that you realize, oh, I could do that part in my head. I'm pretty confident with my signs. Okay?
Yeah,
Okay.
Can we not
Okay, well, here's my, are you listening to me? Can you skip the blue step?
No.
Nope.
Yeah.
You can skip the black step, but you can't skip the blue step. You have to tell me the result of taking care of what's inside that grouping symbol.
Okay.
What you cannot do is come up with, here's your original problem, here's an answer, and then say, give me credit. No. You got to show me one step at a time what you did. Now, personally, I would have taken care of raising the first quantity to the second power first, at the same time that I'm taking care of squaring negative 2y. But this is our first time talking about this, and I want to make sure that you're seeing step by step how things are happening. Now, these two monomials are in exactly the same position. Both of those monomials need to get raised to a power. So now I'm going to do that bit. So here comes what you're doing in your head. So for the first guy, you're going to take 3 and square him, x and square. And the reason why I'm able to write those exponents there and not show multiplication is because the exponents are 1. And I can do 1 times 2. And then this one is 4 times 2. So that's the first one. Second one. Now I'm going to raise each of these parts to the third power, or cube each of them. So I'm going to cube the 4, and I'm going to cube the y squared. That's a brain step. So your brain's connecting what needs to happen. As you're doing those connections independently, you get the results. 3 squared is 9. X squared is x squared. Y to the 4th squared is y to the 8th. We have 4 cubed is going to be 64. And remember we talked about perfect squares, memorizing them up to 20 squared and memorizing cubes up to at least 10 cubed. This is why. You should not be sitting there going, well, let's see, 4 times 4 is 16. 16 times 4 is 64. Okay, unlike yesterday's test, which some of you took upwards of an hour and a half to 2 hours to take, 9 questions, that pretty much exhausts the amount of time you would have had to take your placement test of 50 questions. Those 9 questions are just going to be 9 of the 50 that show up on your placement test. You cannot take 10 minutes per question. You can't. You won't be able to pass that test. Speed is unfortunately one of the determining factors whether you're ready to move on or not to the next level. So you guys need to work on that, okay? So here we got y, 2 times 3 is y to the 6th. So that step is not optional. Now look what we have. I have a monomial times a monomial. So far, this has all been dealing with power to a power. Dealing with that rule of a to the mth raised to the nth gives me a to the m times n. Now we're to Monday's rule. Okay? So now we're going to be dealing with, let's get a different color, multiplying monomials, which talks about if you're multiplying 2 monomials and they have the same base, what do we do with the exponents? Say it loud. Okay, that was one person. You're going to add those exponents. You got to keep straight. When do I multiply? When do I add? Okay. So I'm going to, in my head, link up the coefficients. So I'm going to have this part of the problem. My x's, I'm going to add the I don't have any other x's. I only have the one. Only have the one x. So I have the x squared. On the y's, though, that's where I'm going to do the adding. Again, that's your brain step. The result, let's see, we get 36, 54, and 3 is 57. So 570, oh, that's lousy. 576, x squared, y to the 14th. And that would be your final answer. So in this problem, you have an original problem. You have a result of taking care of what's inside a grouping symbol. You have a result of raising each of the monomials to a power. You get your final answer. So the original black, the blue, the green, the purple are not optional. What's not necessary to show me is the actual multiplication that you've been working on since 3rd grade. I am sufficiently confident that you can do multiplication in your head. Okay, some of you have proved me wrong on some of your tests, but I think that's just faulty error going too quickly. But I think this you could do. Now, should you show how to get 9 times 64? Yeah, if you can't do it in your head, you do it on the paper on the edge. Don't erase it, just leave it there. Never erase work. Okay, it's a waste of time. All right, I'm going to give you guys one, and I'm going to have you guys see how you do on it. So let's see. What are we, number 5? So I'm going to mess with you. Doesn't take much.
It just takes heart and confidence.
There you go. Listen to you. Never.
You gotta
Okay,
love
I'm going to tell you right now, Michael, every time you want to take a fraction and turn it into a decimal, you're making the problem harder. The problem is much easier to do this with fractions. Go for it.
Jackie.
All right, let's hear some of the answer choices you guys came up with. Patrick?
1/8, A to the 6th, B to the 6th,
Okay.
and then
Oh, no. There's only one final answer.
A, B to the 4th. So, oh yeah.
Okay, there's only one final answer, so there's not 2. You get one final answer. Jackie?
Alright, B 10.
Michael? A? Michael A.
32, A to the 6, B to the 10.
Okay. Somebody with a different one? Johnny Ray?
244 over 6. 8 to the 6th power. B to the 10th power.
So we seem to have a commonality, at least, between the answers. Alicia?
I have a question. Is it
John, did you do 32 times 1/8?
Negative 4b.
4B.
It's a negative 4b.
Oh,
No,
wait.
no.
That should be 244 over 8.
Okay.
Oh, it's a 4B.
It's a b.
Negative 4.
If it was a 6, it would be curvy. Oh, that's funny because I think when I read it, I said 4b, and I wrote it with a straight back, which would make it a b. Okay. Okay, Michael. Shh, one more answer, and then we're going to go do it.
4, A to the 6th, and then B to the 7th.
Okay, so we have a lot of different answers. And let's see what happens. So I'm going to cube 1/2. That means I cube 1 and I cube 2.
No.
That's how that works. So that gives me 1 to the 8th. A squared cubed, 2 times 3 is 6. B squared cubed, 2 times 3 is 6. So that's the first part. Next, I'm going to square negative 4, which is going to give me negative 4 times negative 4 is 16, and b squared is b squared. But then I have to raise that whole thing to a power. Well, now I'm going to multiply 16 times 16. Now I'm going to show you a trick. Instead of doing that in my head, I'm just going to write it like this temporarily. You'll see why in a second. And then b squared squared is b2 times 2 is b to the 4th. Now all I have is a multiplication problem. So here's why I did that.
What is 16 times 2?
Shh. I don't want to know what you did. Without me needing to know what 16 squared is, which could be an area of concern because you haven't memorized that, leave it in its unmultiplied form and then simplify if you can. This one I could. 8 goes into itself once and into 16 twice. So that leaves me with 2 times 16, which is 32. And then we get, there's no connecting over there, so we'll take that away. So we just have an a to the 6. And we have a b to the 6 times b to the 4th, and we add those exponents, and we get b to the 10th. Who gave me that answer? Thank you, Michael A.
You're welcome.
And there you go.
That was so hard.